Ensembling is a powerful technique that is used in machine learning to combine multiple machine learnings in order to produce one predictive model. If you think about it, it's pretty much how it happens in real life. No matter what you do, no matter how much effort you put into it, there is still a chance that one individual machine learning model would have issues with producing correct predictions. So, as I mentioned, pretty much like in life, where the collective wisdom of a large population is statistically better than the decision making of a single individual, in machine learning, you can use ensembling, where you take a number of machine learning algorithms, train them with the same data set, and then you apply some kind of combination to their outputs in order to get the final prediction. As it turns out, there are several approaches to ensemble machine learning algorithms. The first of these approaches is known as bagging. Bagging is also known in machine learning as bootstrap aggregation. And the aim for bagging is to reduce overfitting for types of machine learning algorithms like decision trees, for example. And the way this happens is we use a random subsampling of the training data. In a way that we randomly select samples of that data and we train machine learning models using those randomly selected sets of data. And then we repeat the process several times. The immediate result of this is a number of trained machine learning models. And then the way we derive the final result, we assign equal weights to the predicted outputs of each individual machine learning, and we combine the final output. The second major approach in ensembling is what is known as boosting. Basically, boosting is an approach through which we aim to produce a strong learner using weaker learners. So as opposed to sampling data from the input data and training multiple models, which happens in bagging, in boosting, we use the same input data, but we train multiple machine learning models, typically using different values for their hyperparameters. And that ends up in basically using the same learners, and because the method is a sequential method, we are constantly improving the performance of the resulting model. The third and final approach in ensemble is stacking. Stacking consists in simply training a large number of completely different machine learning models and then taking their output, combining those outputs into a final output. So as you can see, all these approaches, whether it's about bagging or boosting or stacking, rely on the relatively simple concept that having a large number of trained machine learning models and combining their outputs to produce the final output is statistically a better approach to get higher quality predictions.